So let's continue our lecture on forces and laws of motion. So let's continue to section 4, everyday forces. So in this section, we're going to try to explain the differences between mass and weight. Second, to find the direction and magnitude of normal forces, describe air resistance as a form of friction, and finally use coefficients of friction to calculate the frictional force. So let's start with weight. So the gravitational force exerted on an object by Earth is a vector quantity, and it's always directed towards the center of the Earth. Now, this magnitude of this force in the scalar quantity is generally called weight. Remember that the gravitational force is a vector, but weight itself is a scalar. Now, weight generally changes with the location of an object in the universe. But so what happens with weight here? How do you calculate weight at any location? So it's generally given by the formula Fg equals mag. So where ag is the free fall acceleration at that location. So we generally consider ag to be g on Earth, which is about 9.81 meter per second square. So weight can be calculated as the product of mass and 9.81 meter per second square. So let's take a difference here. Let's say if you have an astronaut floating in space. So an astronaut's mass does not change. The reason it does not change is because the person mass is made up of the amount of matter present in that particular particle, in that object or the person, while the weight is zero because she is not under the influence of the Earth's gravitational force. Because the acceleration due to gravity is zero, so Fg is zero on her. But remember that mass is not equal to zero. So mass is always a positive value. It generally has some value at all. Next, let's talk about normal force. So the normal force acts on a surface in a direction perpendicular to the surface. Remember this very important, that the normal forces are always perpendicular to the surface, not perpendicular to the ground. Gravitational forces are perpendicular to the ground, while normal forces are generally perpendicular to the surface. Now, the normal force is not always opposite in direction to the force due to gravity. It's always perpendicular to the surface. For example, if you have an object on the inclined plane, the normal force is generally perpendicular to the inclined plane, while the force of gravity is perpendicular to the ground. So remember this example to be important. So next, let's talk about friction. So friction, we divide friction into two types. One is static friction and kinetic friction. So static friction is a force that resists the initiation of a sliding motion between the two surfaces that are in contact and at rest. Remember that friction is generally opposition to motion. So friction is something that opposes motion. Now, static friction is generally a friction, the force that resists the initial sliding motion. Remember that here, static friction means that friction at rest. So when you're starting at rest, the friction that is on the body is generally called static friction. Now, kinetic friction is the force that opposes the movement of two surfaces that are in contact and sliding over each other. Now, remember that here in motion. So friction in motion, we generally have kinetic friction. So remember that kinetic friction is always less than the maximum static friction. And this is an important point because kinetic friction is generally a constant value, while static friction increases with a time and reaches a maximum value. And once it reaches a maximum value, that maximum value is generally always greater than the kinetic friction. So why do frictional forces come into play? More commonly, the frictional forces come into play because of the fact that you have surfaces that are jagged, and the interlocking of these surfaces results in friction. So that is one of the main reasons why you have friction in the first place. So let's consider frictional forces in free body diagrams. So in free body diagrams, the force of friction is always parallel to the surface of contact. Remember this important part. It's always parallel to the surface of contact. And second is that the force of kinetic friction is always opposite to the direction of motion. So remember this main point, that it should always be opposite to the direction in which the body is moving. Now, to determine the direction of force of static friction, we generally use the principle of equilibrium. For example, if an object is in equilibrium, the frictional force must point in the direction that results in a net zero force. For example, let's consider an inclined plane. Now, the weight is pushing it downward, so which means that the friction is being acted upward. So this is friction, and this is the force. Now, one of the main ways we can use friction as a value, so how do you determine friction? We use the coefficient of friction. So the quantity that expresses the dependence of frictional forces on a particular surfaces in contact is generally called coefficient of friction. Now, coefficient of friction mainly depends on one of the main factors is always the surface. So the type of surface and the size, shape of surface. Now, so coefficient of kinetic friction is the kinetic frictional force by the normal force, while coefficient of static friction is the maximum static force, static friction by the normal force. So we use mu s and mu k. So these are mu s and mu k on different surface combinations. For example, wood on wood would have a mu s of 0.4 while mu k would be 0.2. Ice on ice would be 0.1 mu s and mu k would be 0.03. And steel on steel would be mu s 0.74 while mu k is 0.57. So let's try and solve a problem. So what is given here? So a student attaches a rope to a 20 kilogram box of books. He pulls with a force of 90 Newton at an angle of 30 degrees with the horizontal. Now the coefficient of friction between the box and sidewalk is 0.500. They're asking us to find the acceleration of the box. So remember that here they are giving us the kinetic friction, so which means that the body is in motion. Now for that condition, let's try to understand the actual object in its motion. So now we have the body traveling in the horizontal direction. So with the respect to the horizontal, it travels at an angle. So this is the applied force. So you have the gravitational force, you have the normal force, and you have the friction. So with respect to the horizontal, we have a 30-degree angle, and this is 90 Newton. And you have the normal force, the gravitational force, and the kinetic friction. Now remember that this is still moving forward. So there are two conditions to remember. So first, there is net forward motion, and there is no net upward motion. So which means that the force along the y direction is equal to 0. And the total force along the x direction is equal to max. So ax here is the value that we are going to try to find. So in the data, what is given? So the mass is given as 20 kilograms. The angle theta is given as 30 degrees. The applied force is given as 90 Newton. And we also have the coefficient of friction mu k, which is given as 0.500. Now, so let's first try to resolve this vector. So you have two vectors that are going to develop. So this becomes 90 cos theta, so which is cos 30 degrees. So this is going to become 90 sine 30 degrees. So you have 90 cos 30, which gives you 77.9. So F applied along the x direction is going to be 77.9 Newton, and F applied along the y direction is going to be 45 Newton. It's going to be 45 Newton. Now, so we have everything that we need. So which means that we are going to modify the actual diagram again. So let's try to draw the modified diagram. This is the box. You have the gravitational force downward, the normal force upward, and the applied force along x direction, and the frictional force. So this is the kinetic friction. This is the applied force, and this is the applied force along x, the applied force along y, and this is the normal force, and this is the gravitational force. So the two conditions that we have are sigma fx equal to max and sigma fy equal to 0. So because the second one is simpler, let's consider sigma fy equal to 0 first. Remember that forces are vectors, so which means the direction matters. So let's consider the forces upward as positive, the downward is negative. So it becomes Fn plus F applied y minus Fg equals 0. Now, so with that into the condition now, so let's consider the next thing. So remember, the idea here is to take up the values that are present there and write down the answers. So first things first, we need to remember is that we do not have Fn here. So Fn plus we only have the applied force along y direction, which is 45 Newton, minus the gravitational force. How would you calculate the gravitational force? Which is mg. So m is 20 times 9.81, so which is going to be 196.2 Newton. So minus 196.2 Newton is equal to 0. So Fn becomes 196.2 minus 45. So 196.2 minus 45 becomes, so Fn here becomes 151.2 Newton. So we have the normal force now. Now let's get into the x direction quantity, so which is sigma fx equal to max. So we are calculating this acceleration right here. Again, anything towards the right is positive, anything to the left is negative. So to the right we have F applied x minus Fk equals max. Now F applied x, we have already calculated it. That value is 77.9 minus Fk, the kinetic friction. So remember the formula, mu k is Fk by Fn. So from this we can write Fk as mu k times Fn. So we can write it as mu k times Fn equals to max. So 77.9 minus mu k is already given 0.5 times Fn. The value is 151.2 is equals, m here is 20 times ax. So 77.9 minus of 151.2 times 0.5. So that value becomes 2.3 equals 20 times ax. Ax becomes 2.3 by 20. So you have 2.3 divided by 20. So the acceleration ax becomes 0.115 meter per second square. So or 0.12 depending on the value. So we can write it down as 0.12 meter per second square. So that value becomes your final acceleration of the object. So this is how you solve a problem involving friction. Next, let's talk about air resistance. So air resistance is also a form of friction. So whenever an object moves through a fluid medium such as air or water, so the fluid provides a resistance to the object's motion. So for a falling object, when the upward force of air resistance balances the downward gravitational force, the net force on the object is 0. The object continues to move downward with a constant maximum speed. This speed is generally called as the terminal speed. Let's get into some of the fundamental forces. So there are 4 fundamental forces in nature. The first is electromagnetic force, gravitational force, strong nuclear force, and weak nuclear force. So these 4 forces are generally called as the field forces, and these are the most common non-contact forces. So until now, the forces that we discussed are contact forces. These are the forces that require some form of physical contact for them to act on the other body. But these 4 forces are generally called field forces, and their presence can be felt without having any contact. So with that, we end our lecture on forces and laws of motion. I will see you again in the next lecture.